November 2013, paper 1 combination. This question will cover derivative as well as integration, that is a definite integration. Let's start with this first part. Maximum mark 15 total. Let f of x is equal to ln of x bracket square divided by 2 for x is greater than 0 for obvious reason, because ln of negative number does not exist. So it is not x square, it is a ln of x the full bracket square. Show that f dash x is equal to ln x upon x. Look at this very closely. This is not a quotient rule. Denominator is a constant. So it's only ln of x bracket square. You can use a chain rule. I'm using directly. If I'm using directly, I'm writing first f of x is equal to 1 by 2. ln of x bracket square is same as ln of x bracket square upon 2. 1 by 2 as it is. When I'm taking a derivative, constant derivative, if it has x with it, don't take that. I'm keeping 1 by 2 as it is. First, when I'm taking a bracket derivative, bracket contains ln x. To take a derivative of x, first we need to take a derivative of ln x. And to take a derivative of ln x, first we need to take a derivative of bracket. So first you take a bracket derivative, just like what your x raised to n will come down, n will come down, x will remain as it is, raised to power is decreased by 1. So here 2 will come down, ln of x will remain as it is, raised to power is decreased by 1. As it is a chain rule, we took a derivative of a bracket which contains x, but we haven't taken the derivative of actual ln x. So we will take the derivative of ln x. That means derivative of ln of x, ln of x. ln of x derivative is 1 upon x. 1 upon x into ln of x is ln of x upon x, which we want to show that. Now next one, there is a minimum on the graph of f. Find the x coordinate of this minimum. Minima, maxima, that means single derivative should be 0, because at minimum point or at maximum point, if I'll draw a tangent, the tangent is a horizontal. And why we draw a tangent? Because slope of a tangent is the slope of a curve at that point. At maxima, minima, thus tangent is exactly horizontal, so slope is 0. So we found out already slope, ln of x upon x. Equate that to 0. So ln of x upon x is equal to 0. So ln of x is equal to, take x on this side, becomes 0. ln of x is equal to 0. Now we are using a logarithmic, because we want to convert x, we want to find out x, we have to cancel ln. We know the rule, log of x to the base of whatever a, say, is equal to y. If I want to remove that log, base goes on the other side, like a, other side becomes a raised to, that is y, log is cancelled and you are left with x. Same thing, ln of x is also written as log of x to the base of e, and that is equal to given as 0. So base goes on the other side, that is e here, 0 becomes raised to, like here, log is cancelled and you are left with x. So x is equal to e raised to 0. Anything raised to 0 is equal to 1. So x is equal to 1, and we want only x coordinate of that minimum point, which is equal to 1. C part, g of x is equal to 1 upon x. They have given this graph. The following diagram shows the part of the graph of f dash and g. You can see here f dash is this one and g is this one. The graph f dash has an x-intercept at p, that means this. Write down the value of p. As we know that f dash x-intercept means what? Y is equal to 0. That means f dash x is equal to 0. F dash x is equal to 0 means what? Ln of x upon x is equal to 0. Again ln of x is equal to 0. Again x is equal to e raised to 0. E raised to 0 is 1. That means that x value of f dash is p is equal to 1. That is why they said write down. But I need to show some working. That is why I repeated this full working over here. Because x-intercept, that means y is equal to 0. But y in this case is your f dash x. So that is equal to 0. So we got the same value, but name is different. Now they are naming as p. Next part, the graph of g, intersects the graph of f dash, and the graph of g intersects the graph of f dash, and the graph of g intersects the graph of f dash, and the graph of g intersects the graph of f dash, and the graph of g intersects the graph of f dash, and the graph of g intersects the graph of f dash, and the graph of g intersects the graph of f dash, and the graph of g intersects the graph of f dash, and the graph of g intersects the graph of f dash, and the graph of g intersects the graph of f dash, and the graph of g intersects the graph of f dash, and the graph of g intersects the graph of f dash, and the graph of g intersects the graph of f dash, and the graph of g intersects the graph of f dash, and the graph of g intersects the graph of f dash, and the graph of g intersects the graph of f dash, and the graph of g intersects the graph of f dash, and the graph of g intersects the graph of f dash, and the graph of g intersects the graph of f dash, and the graph of g inters when x is equal to q. You can see here both graphs are intersecting. The rule is that whenever two graphs intersect, whether the lines or curves or line and curves, that means solve simultaneously. Now if it is a paper one, basically you have to equate them, because it won't be a complicated part. Paper 2 you can directly use a graphical mode and show that graph. Okay, so right now I can see that both are graphs intersecting. I know g of x graph is 1 upon x. I know f dash x value is ln x upon x. So I'm equating g of x is equal to f dash x. So 1 over x is equal to ln x over x. Both denominator same, only single term. So I'm cancelling x and x. What is left? 1. What is left? X. Again I'm using the same rule. Ln of x is basically log of x to the base e. Base goes on the other side. Other side becomes a raised to, and log is cancelled. So what is left? X. X is equal to e raised to 1. But I want that name value of that x is q. So q is equal to e. So this point has a x value e, which is what? Q. Last part, let R be the region enclosed by the graph of f dash, the graph of g, and the line x is equal to p. Show that the area R is 1 by 2. X is equal to p, that means p value we've already found out, which is 1. So let's say this is my 1. This is where they intersect. Okay, I'm extending this up to here. So if you'll see, upper one is a g dash, lower one is a f dash. I want to find out this area. So I will take the integration of g with lower limit is 1 and upper limit is e. I will get this full area. Then I will subtract the graph of f dash integration again with lower limit e and upper limit e. Then I will get this required area, which is capital R, and we want to show that it is equal to 1 by 2. Let's start with R is equal to upper one is g of x dx with lower limit 1 and upper limit e, minus lower graph is f dash x dx with lower limit 1 and upper limit e. What is g dash? What is g of x? 1 upon x dx 1 to e, and f dash x integration. As we know that derivative and integration are reverse process of each other. So integration of f dash x would be f of x. And what is f of x? F of x is your actual function, that is ln of x bracket square over 2. So I'm writing directly 1 by 2 ln of x bracket square. You don't need to show the integration, because integration of f dash x or integration of a derivative is the actual function. So actual function is ln of x square, ln of x bracket square upon 2. So 1 by 2 ln of x bracket square with lower limit is e and upper limit is e. Lower limit is 1 and upper limit is e. Now what is the integration of 1 upon x? There is a formula. In the formula booklet, you can see integration of 1 upon x dx is ln of modulus of x plus c. Don't use c because we are using definite integration. So I am writing ln of x, lower limit 1, upper limit t. When we take integration, do not show integration. Write down lower limit and upper limit behind the bracket. 1 by 2 I am taking outside. Ln of x bracket square, lower limit 1, upper limit e. Now start substituting upper limit and lower limit. X value first take e, so ln of e, minus lower limit ln of 1, minus 1 by 2. X value take as e, ln of e bracket square, minus ln of 1 bracket square. Ln of 1 is 0. Ln of 1 is 0. Ln of e is 1. So this is 1, this is 0. Minus 1 by 2. Ln of e is 1, 1 square is still 1. Ln of 1 is 0, 0 square is 0. 1 minus 0 is 1, 1 by 2, 1 minus 0 is 1, 1 by 2, 1 minus 1 by 2 is 1 by 2. That is what we want to show, that R is equal to 1 by 2. Thank you.